Today we'll be talking about Lewis structures. We've talked about chemistry in various forms, wanted to play around with Lewis structures. Later I'll be cooking, so I've got these tongs here. I guess I'll be juggling them too, but I can use them for a pointing here. All right, so Lewis structures. If you take a look here, we've got the electronic octet, which is the key to the Lewis structure. I've got 5 simple steps: valence electrons, drawing the skeleton, excess electrons, satisfying the octet, total electrons, sort of a checking what you've done in the last 4 steps, or in the first 4 steps, I should say. All right, so let's build a few of these things. The hydrogen molecule. Each hydrogen atom has 1 electron. How can you do something like this? Well, guess what? You go to the store and you buy yourself a pizza pie plate, and then you put some white paper on the back. And what we're going to do today is we're going to use magnets. So we've got some magnets in various forms. I've got these refrigerator magnets, and each of these refrigerator magnets will be useful for identifying a bond which would have 2 electrons. So when my associate goes to the close-ups, we'll be building these structures. Fact is, he could even zoom in a little bit more if he desires. So let's build a hydrogen molecule. First, we'll need a hydrogen atom, and we'll need a bond between the hydrogen atom and another hydrogen atom. In this case, does this satisfy an octet? No. The only reason we use the octet is for purposes of identifying elements that would have the potential for 8 electrons surrounding them. In this case, we have hydrogen, which only has 1 electron to donate. This hydrogen has 1 electron to donate. So the octet rule is not applied here. In this case, though, we form the hydrogen molecule. All right? So the octet rule will bring that into play when we get to molecules that will have the opportunity for more electrons. Okay, next we're going to do the nitrogen atom. The nitrogen atom has 10 valence electrons. Each nitrogen has 5 valence electrons. So what we're going to do in step 2 is to draw the skeleton. So once we've got and of course these are diatomic, so it's very simple. A skeleton would just be putting one next to the other. But we need to put the electrons around here. So step 1, we've got 10 electrons to go around these 2 nitrogen atoms. How are we going to do this? Well, let's first put a bond here. That takes up 2 electrons, okay? Well, guess what? We've got 8 more to go. Let's put another bond here. Thus far, we've got 4 electrons. And yet another bond, a triple bond here. Thus far, we've got 6 electrons. And guess what? We can put, with these types of magnets, 2 electrons on the end. All right, so 1, 2. These are much more powerful magnets. And 1, 2. All right, so here we go. Very powerful ceramic magnets. All right, so there is our nitrogen structure. And then we're going to check this. Do we have 10 electrons? Well, we have 2, 4, 6, 8, 10. 10 electrons. The nitrogen molecule has a triple bond. Nitrogen is inert. Why? Because it's got a triple bond. Very difficult to break that nitrogen molecule apart. All right. Next, we're going to go to oxygen. If you go back to my board over here, we've got the oxygen molecule O2. All right, oxygen, group 6 of the periodic table. Each oxygen atom has 6 valence electrons. So we're going to have to put together 2 oxygen atoms, which means 12 total electrons. So let's do that. Like this, we'll just leave some of this here, and then we can escort them to the molecule. So step 1, we identified the number of valence electrons is 12. Now we're going to put the 2 atoms together. Let's start putting some bonds together. Well, if we put 1 in the middle, then that means we have to have what? 10 electrons to go around. So let's start putting a couple more in the middle here. Once you start playing with Lewis structures and learning how they work, it's so easy to do this. All right, so we've got 2, 4, 6, okay, and another 2 over here. Okay, so let's put one over here and one over here. These are very powerful ceramic magnets. Okay, here we go. There's another there, so that's 2, 4, 6, 8. And let's complete this. Some more refrigerator magnets. Okay, or excuse me, ceramic magnets. 2, and another one over here. And now we can do the final step. Do we have the octet? Let's take a look here. Each oxygen atom should have an octet. All right, so we take a look over here. We have 2, 4, 6, 8. All right, this is a covalent bond. These 4 electrons are being shared by the 2 oxygen atoms. All right, so 2, 4, 6, 8. Octet satisfied for this oxygen atom. How about this one? 2, 4, 6, 8. Yes, the octet is satisfied for that oxygen atom. And total, we have 2, 4, 6, 8, 10, 12. 12 electrons. So we started with 12 valence, we end with 12 valence. Voila, the oxygen molecule. However, if you study the oxygen molecule, you'll find out that it is not a diamagnetic structure, it's a paramagnetic structure. It actually would be, if you liquefy the liquefied oxygen would be attracted to the poles of a magnet. All right? So you'll need molecular orbital theory to understand that. You will have unpaired spins in the oxygen molecule.